Hello, my name is Caleb Yates, and I'm at McAllister Park. This is my geography in my backyard project. Right now I have a quick little map of the park that I'll be at, so let's get into this. Alright, first we're going to look at a stream in a small scale, just kind of some of the characteristics of streams and waters. So first I'm going to turn my camera around so that you can see what we're looking at here. First we have an example of what used to be, I guess, a stream. Usually this would only have water, I assume, when it is raining, which, if anything, this would make this an ephemeral stream. Ephemeral streams are very common where we are right now in San Antonio, and probably in most parts of Texas. So first, I want to look at what we have on this left side, where we have a cut bank. This is where the water would be hitting the side of the bank when it is turning to the side, right there. And the water would be moving faster this way. Now we have an example of a small scale point bar. The only reason why this is small scale is because there's not really any remaining sand that would be usually at a point bar. But looking at the side here, we see that the water is cutting into the ground here, giving us a layer under this. So then also what we can see is the rocks being carried around by the water, and these rocks over here being larger around sort of the side of the river, right, or the stream right here, and I guess smaller rocks being deposited around this side. So other than that, this is a very small scale again of kind of what we've been seeing with streams. Here I see that we have a larger scale example of what an ephemeral stream would do to the terrain in the ground, cutting into the rock. So let me show y'all just in more detail what I'm looking at here with this. Across this side, we have the results of another cut bank where the water would be cutting into the side. All along the side right here, we have this layer where the water would be affecting that. But right now, obviously it's dry, and that is because this would be an ephemeral stream, being only a stream that is filled with water when it is raining. Now, looking at the side here, we have a look at limestone, which is common in where we're at in San Antonio, Texas. Looking also here, we have a result of first biotic weathering with some of the moss right here. You can see kind of that bluish green color distorting that. Then we also have some other examples of biotic weathering with the roots of the trees growing into the stone that's breaking it apart. And then we also have an example of chemical weathering. That's going to be with carbonic acid, carbonation, coming from rain that is falling and bringing different elements with it. This is a great example right here of carbonic acid, as we see this little hole in the stone, in the rock right here, in the limestone. And there's a lot of this carbonation and a lot of different elements that are working on these things to discolor the limestone that we have. As a result of this, there is mass wasting, as we see a lot of rocks that are being that have fallen from the from this side right here, from this rock wall. And this is a great example of mass wasting in process, since this has already been cut into. Now it's just waiting for all the other sides to be cut into so that it is eventually going to fall from this side right here. So now let's look at some other examples of different natural processes at this park. Let's look at another example of the result of fluvial processes. Now, fluvial processes are kind of what I've been mainly focusing on so far, about how different things would be moved with erosion mostly. And fluvial processes are basically just processes that are carried out by water. And water is the strongest agent of carrying out such processes to move material, to cut into rocks, to do many other things. It is so much stronger than air, with comparing that to aeolian processes. But let's look at this next ephemeral stream. This is not a very deep ephemeral stream, but it is evident that there would be water here. First, let's look over there at kind of the rocks that are lined up here. As we see, they are mainly condensed at the center of this, which would be where the fastest part of the stream would be, as it turns. And we can see a little meander at the side right there, or at least a little turn there. Perhaps not so much meandering yet. Comparing that to this side, this is a lot more straight, just because the water would be moving downward, as water does move down. Now, looking at this process here, again, the bigger rocks would be carried and would be moved at a faster speed, and would be dropped off whenever there is not sufficient speed for the water to keep carrying it around. And with erosion and water carrying rocks across, usually there could be evidence of saltation too, where rocks would be bouncing on the bottom of a river as it would be crossing around, or crossing across land. And perhaps maybe some of these rocks could be carried around by saltation if they're bigger rocks, but a lot of the smaller ones could just be carried about just easier by the water. So now I want to look more specifically at the type of stone we have and the different types of weathering processes that can affect it over time. In San Antonio, we mainly have limestone in our ground, and there are many different types of weathering that would happen to it. First, we have chemical weathering, and there's also biotic weathering and physical weathering that can happen and would affect it in many ways. Let's look at the limestone that I want to choose to just look at and see all those different processes in effect, because there is a lot to take apart from this. The first thing that would be easiest to pick out from this is the discoloration that we have with the limestone. Honestly, it looks very blended in with the soil that we have here, and it might be a bit difficult to kind of pick this out and see it at first glance. It doesn't necessarily pop out to the eye, but looking at limestone, usually it is a more bright yellowish color, but with this, as a result of chemical weathering with different elements like carbonic acid, we get a more greenish, brown, or grayish color with this. Let's look then more specifically at these little like small holes in the ground. So this is a result of carbonic acid that would make little holes in the ground like that, or make little holes inside of the limestone. Looking at some more of the different types of chemical weathering that can happen to these rocks, let's look at the red color that we have here. With metals like what we use to make cars, or just any type of even natural metal in the ground, oxygen would affect this by turning them red over time due to exposure to oxygen in the atmosphere. Now, just with some of these rocks here, they have been turned red over time, and we can see as a result, the outside would look red. If we were to cut into any of these rocks or look on the other side, they don't seem to be as red as they do on the other side, indicating that due to exposure to outside oxygen in the atmosphere, these have been changed. And looking also at just this rock again, with the carbonic acid with other elements in the atmosphere turning it to this darker color, if we were to cut open into this, we would see that it would be a lot more white and a lot more bright. Let's look at this piece of rock over here on the side. We can see on the left side there is first the darker greenish color that is a result of carbonation, and then we see the reddish color, I would say, as a result of oxidation. And then on the side, this is not as affected just because it has been recently cut off due to mass wasting. Over here on the side, there was an example of some cracks in the rock due to different types of things that can happen. Perhaps maybe looking on the side right here, we see the result of a root growing through the ground, which is an example of biotic weathering. And then we see some more cracks due to different things like water that can have material like carbonic acid to rain on top of it and then crack the rock over time. So then it would eventually fall, like this rock right here, down from the rest of it. Now finally, I just want to look at, again, putting this all together with how are we going to look at limestone working with the different types of weathering happening on it, and then having the different elements of streams affecting the elements too, affecting the rock, affecting its shape, and then eventually how it moves, since there's always progression in the environment. There's always progression over time. So let's just look at this real quick. Looking at this ephemeral stream, we see at least just the results of an ephemeral stream. We don't have any water currently over here, but we see a lot of cracking on this rock, and eventually this is imminent mass wasting just waiting to occur. And there is the result of mass wasting on in the middle of this right here, where we see a lot of the rock falling off. We see some layer of what would be the result of a cut bank, where at least this side right here would be cut into just because of the water that would be running into it and be diverted onto the side. So also, I mean, yeah, the three different types of weathering is evident here. And as I've been looking at the three different types of weathering throughout this whole period that I'm over here, we see again the effects with the environment on it with chemical weathering. And we see the tree growing into it with its roots, biotic weathering. And then with physical weathering, a lot of it is just the physical rock breaking down due to different things like the like water freezing and breaking onto it. But a lot of that isn't really happening over in San Antonio, Texas, just due to our warmer temperatures and the such. So finally, just looking at this, yes, a lot of actually a lot of the stream is evidently affecting the side here where it is cutting into the ground, and it is going that way where the eventually the land would be moving that way, and the bank, if I'm not mistaken, would be progressing in that direction just due to the more exposure with water. That is all I have with my visit with McAllister Park. I enjoyed making this video. I learned a lot during the class whenever I had your class, Dr. Yeager, and I hope that this video was informative and that it was able to show how much I've learned throughout this semester.